Higgs boson,
चंद्रशेखर लिमिट,
string theory,
न्यूट्रिनोस,
quantum entanglement.
कुछ समझा क्या?
Ever felt bored and confused while reading lengthy physics textbooks or articles?
Yeah, on God, bro.
I'm Arnav,
And I'm Pratham.
and welcome to Quark Talk, where we decode all the complexities and simplify these intricate concepts in physics.
They may have seemed too complex to understand until now. July 21st marks 1 year of the release of Oppenheimer, and we wanted to do something special to commemorate it.
Yep.
So, in today's episode, we're going to discuss about the life and work of Dr. J. Robert Oppenheimer. But first, I think we should talk a little bit about the movie. So,
Sure.
Arnav, what did you think about it?
I mean, it was great, first of all. Second of all, the trend that time was Barbenheimer, as you know. But I didn't really adhere to that. I just watched Oppenheimer twice.
Of course.
And it was a good movie. It was lacking in the part where I didn't have much physics related concepts, which I didn't like that much. But it was the cinematography, the direction, was very good. It was top notch.
Even I felt that I would have appreciated a movie which was more on the Manhattan Project and Trinity itself rather than
Fair.
Oppenheimer, because I didn't really want to get into
His life details.
yeah, and all of the communist propaganda that was around his life, whatever.
Yeah.
But I have to give credit where credit is due, and it definitely felt like an Oscar-worthy movie.
That's right.
Yeah. I was just thinking about it, and I feel that J. Robert Oppenheimer just might be the most important physicist to have ever lived. I mean,
Okay.
he never won a Nobel Prize, but he changed the world more than most Nobel Prize winners. Under his leadership, the best physicists of the 20th century built the atomic bomb, and of course, forever changed the course of history.
I mean, that's true. And he's affected every single war waged and every single peace that was settled since the end of World War II. He also, sadly, created a way for humanity to destroy itself.
But how did that happen? I mean, Rome wasn't built in a day. So
Yeah.
let's back up a bit.
So, when J. Robert Oppenheimer was 21, he spent days and days in a corner of J.J. Thomson's basement laboratory attempting to make thin films of beryllium, which were used to study electrons. When Roe was in Cambridge and doing some lab work under his teacher's orders, he was clumsy and not good at his work. Soon, he was avoiding his duties in the lab, spending his time listening to lectures and reading physics journals. Later, it was 1925, and young Oppie was becoming fascinated by the new world of quantum mechanics. Despite being surrounded by brilliant physicists like Rutherford and James Chadwick, Oppenheimer was still unhappy. He wrote, "I'm having a pretty bad time. The lab work is a terrible bore, and I'm so bad at it that it's impossible to feel like I'm learning anything."
Yeah, that's why he probably dipped from Cambridge, and in the summer of 1926, he traveled to the University of Göttingen. The chairman of the department over there was Max Born, who just 2 years earlier had coined the term quantum mechanics.
Okay, interesting.
Yeah, it was in his paper Quantum Mechanik with a K.
Germans.
Yeah, but we love our German listeners, just saying.
Yep.
Born was reportedly a thoughtful and gentle teacher and had nurtured the likes of Werner Heisenberg, Wolfgang Pauli, Enrico Fermi, and Eugene Wigner.
Basically, the who's who of quantum mechanics, right?
Yeah,
And those are big names.
of course. The class that Oppenheimer was in was also extraordinary, including people like Paul Dirac and John von Neumann. And whereas the academic culture at Cambridge focused on experimental physics, Göttingen was all about theoretical physics, and under Max Born's extremely good mentorship, Oppenheimer thrived. His mental health improved, and he finally found a community of people who were as blessed with physics as he was.
I mean, good for him, right?
Yeah.
So, to prove that, he wrote a letter to his brother and he said that he found the work hard. But he also said that he found it almost pleasant. He was thriving and his talent was being recognized. Moreover, Born, his mentor, wrote that Oppenheimer was a man of great talent. So, keeping up with this, Oppenheimer, when he was 23, graduated with his PhD in physics.
Wait. That's too young.
He's Oppenheimer. He's Oppenheimer. So, he wrote his thesis in German on the quantum theory of continuous spectra.
All in all, he published more than a dozen papers in only 2 years. I mean,
That's a lot, though. That's like what?
Yeah, just one paper every 2 months. Like, please.
No, like that's so easy, right?
Yeah. And
Child's play.
many of them expanded upon the work of Werner Heisenberg, who was just 3 years older than Oppenheimer.
Wait, what? Who Heisenberg?
Heisenberg's uncertainty principle.
Wait, it's that Heisenberg?
Yes, that.
No way.
Yeah. At that time, it was thought that getting significant amounts of energy out of radioactive atoms was impossible. I mean,
Okay.
it was thought that it was as impossible as reversing entropy.
If you know, you know.
And it was also thought that unstable atoms would just decay at random, unpredictable times. And surely there was no way to control that, right? Right?
Well, okay. You could take a proton and accelerate through a large electric field to break an atomic nucleus. This is exactly what John Cockcroft and Ernest Walton did in 1932. They accelerated protons into lithium nuclei, breaking them apart. Later, they even won a Nobel Prize for it. But whatever. Now, the problem arises because a proton is positively charged. So it's repelled by all nuclei, which are also positively charged.
Correct. Yeah, we spoke about that in episode 1, right?
Yep. So to accelerate the protons, they had to use a lot of energy. And even then, only about like a 1 in a billion protons actually hit and split a lithium nucleus. So, I mean, this is not an effective way, right? So,
But there is another one.
Okay.
There's another way.
Okay, what is it?
Yeah. A neutron.
Okay.
In 1933, Leo Szilard was thinking about how you could use neutrons to split nuclei. Then he suddenly realized that if there was an element which was split by neutrons and which would also emit 2 neutrons when it absorbs 1 neutron.
So basically like a tree that branches out.
Yeah. So if such an element had a large enough mass, it could sustain a nuclear chain reaction as we now know it. But the thing is, nobody knew if there was an element that had a kind of nucleus that would actually do that.
So a couple of years later, German chemists Otto Hahn and Fritz Strassmann had successfully split an atom of uranium by bombarding it with neutrons. So bombarding is it like because that's to increase the chances of it actually being split as rather than the 1 in a billion.
Correct.
So Oppenheimer wasn't impressed with this though because people and he himself said that was impossible. So Alvarez, one of Oppenheimer's associates, conducted the same experiment to prove it to him. Oppenheimer he not only agreed that the reaction was authentic, but he also speculated that in the process, extra neutrons would boil off.
But the best part is that he did all of this in 10 minutes.
Okay, 15 or 10, yeah, whatever. So
Yeah.
that could be used to split more uranium atoms and thereby generate power or make bombs.
Yeah. When a single atom of uranium-235 splits apart, it loses a bit of its mass, which is released as energy. E is equal to mc squared.
True.
It's a small amount, but atoms are also small, right?
Like really?
In a 1 kilogram lump of uranium, there are about a trillion atoms. So the energy quickly adds up. And soon, almost everybody was convinced of the fact that this process called fission would give you energy.
Including Oppenheimer.
Yeah. And in August of 1939, Einstein, who just 6 years earlier had believed that nuclear bombs were impossible,
Like Oppenheimer.
yeah, agreed that there was a possibility of making a nuclear weapon.
So Franklin D. Roosevelt, the then president, created the S1 committee with the explicit goal to develop an atomic bomb. And in May 1942, Oppenheimer was hired onto the committee to be the coordinator of rapid rupture.
But wait, why was he selected? Wasn't he doing theoretical physics?
Well, after completing his PhD at age 23, as he said, Oppenheimer became a physics professor, first at UC Berkeley and then at Caltech.
Dream schools.
The brilliance that he had shown under Max Born's tutelage didn't fade. Indeed, it blossomed into a remarkable but strange career. And in the 15 years after finishing his PhD, he made many important contributions to everything from nuclear physics to quantum field theory and even astrophysics. But those all are topics for another episode. So, although we said bro didn't ever win a Nobel Prize,
Poor chap.
he was amazing with people. He was a natural and charismatic leader. And this combination, this charisma and this ability to generate ideas that would serve him well were just invaluable for the next phase of his life.
Yeah, one day, General Leslie Groves was appointed responsible for the development of the atomic bomb. With a genius stroke, he chose Oppenheimer to be the science director of the soon to be established Los Alamos lab, the famous one, yes.
Yeah.
But Oppenheimer had no prior administrative experience over a large project like this. And furthermore, he was just a theoretical physicist.
Yep.
He didn't know anything about equipment. And to add on to that, there was also the problem of Oppenheimer's political stance. I mean, he had links to the Communist Party, and his wife, Catherine, was also a member of that party. But Groves was impressed by Oppenheimer. He knew that Oppenheimer's ability to understand problems not just in physics, but chemistry, engineering, and metallurgy would be invaluable. He thought that Oppenheimer was, quote unquote, a real genius. Ultimately, Groves was convinced that Oppenheimer would be the person that would build the atomic bomb before the Nazis, and that was all that mattered to him.
Yep. So, as the head, Oppenheimer estimated that he'd need around 6 scientists and a couple of more engineers to build the bomb. But bro was off by a lot. In the end, 764 scientists worked for the Manhattan Project. 302 of them were at the Los Alamos site. Plus, over 600,000 people in total were involved with the making of the atomic bomb. Now, the only part left was to understand how many neutrons from one atom hit the next atom would hit it if they're causing it to split and release more neutrons, like a domino effect, right?
Yeah.
So if on average the number is 1, there'll be a stable, self-sustaining chain reaction. But it won't grow. That's basically like nuclear fusion, right? That's what powers the nuclear reactors that we use for energy. So if it's less than 1, the reaction will die down. And if it's more than 1, the reaction will grow. Are bombs.
Wait, isn't this thing what we call as the multiplication factor today?
Yep, that's called K. So another important term here is a critical mass of the bomb. Basically, the minimum amount of fissile material needed to make a nuclear chain reaction.
Okay, you just have to bear with these definitions for now, but they'll help you as you're listening later in the podcast.
Fair, yeah. So plutonium-239 was chosen as a material, not only because it was a great fuel, but also because it had a low critical mass. And moreover, it was cheaper to make than to separate uranium-235. And also, the last but not least, it was also reacting too quickly to be used in a gun-type device.
But not a bomb. So, the prototype was made of beryllium and polonium, separated by a layer of nickel and gold. The basic idea was that when the explosive detonated, the shockwave would mix the beryllium and polonium together, and then the alpha particles from the polonium would cause the beryllium to release a flood of neutrons, basically. And this would set off the nuclear chain reaction. At least that was the hope. I mean, an atomic bomb had never been made before.
Yup. So, it was 1945 and the new president, Harry Truman, wanted to test the weapon before the start of the Potsdam Conference. The conference was going to begin on the 17th of July, and the earliest date that was, like, everything would be ready for the trial test was just one day earlier. So that's when it was scheduled.
Of course, वरना climax कैसे बनेगा?
Last minute work. And it was codenamed Trinity. The night before the test, Oppenheimer was nervous. There were so many things that could go wrong. Maybe he thought that more terrifying than the idea of the bomb not working was that it would work too well. He had discussed with Arthur Crompton a possibility that the nuclear test could end the world by causing the entire Earth's surface to become a giant fusion bomb.
In the movie, by the way, he discussed this with Einstein, but whatever.
Yup.
Anyways, back to Trinity. It shone brighter than in daytime. The shockwave was felt from over 160 kilometers away.
That's a long distance though.
Yeah. The mushroom cloud from the bomb rose to 12 kilometers in the sky, and it was a bomb that had the power of more than 25,000 tons of TNT. And the rest was history.
Yeah.
Later, Little Boy and Fat Man, which were basically the names of the bombs that were made by the Americans. Yeah, I know, it's not very bright, but
yeah.
They killed about 225,000 people, and 95% of those people were civilians.
So sad.
After the war, Oppenheimer became a national hero. His portrait was on the cover of Time magazine, and he basically became a household name.
Later, though, he was essentially accused of treason and espionage because of his suspected ties with the Communist Party. Like, we heard of that so many times before. And in December 1953, because of all this, he had his security clearance suspended. Now his face was grim and in black and white, and again on the cover of Time. His security hearings were international news.
But we need to keep in mind that he strongly opposed the hydrogen bomb, which was 400 times more powerful than Trinity, by the way. Finally, recalling the moments after the Trinity test, Oppenheimer said that he thought of another verse from Hamari Bhagavad Gita. He knew that the world would not be the same. He said,
"We knew the world would not be the same. Few people laughed. Few people cried. Most people were silent. I remembered the line from the Hindu scripture, the Bhagavad Gita. Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds." I suppose we all thought that one way or another.